Okay, so hi, welcome again, and welcome to the next paper which I'm presenting, which is resources for brewing beer, which contains reproducible reference models and statistical analysis. So this was the work done by Ehsan, who couldn't join himself, but I'll be presenting for Ehsan for the presentation. Yeah. So, like I told, probably previously discussed also in the previous slide, but yeah, BEIR was a benchmark which we kind of introduced in 2021, which measures sort of out-of-domain generalization in retrieval models. It contained 18 different retrieval tasks across a wide range of domains. So if you see the slide, it has been taken from the BEIR benchmark paper. So we have different sort of categories of retrieval tasks there, ranging from fact-checking to argument retrieval to news retrieval and so on and so forth. The main metric which we used to evaluate all the models on BEIR was the macro average NDCG at 10. So the question was, like, since we have the BEIR benchmark and the paper coming out of it, I think so we wanted to see in this further study, like, what's sort of missing in the BEIR benchmark at this point of time. And we found 2-3 things which we found are currently missing from the benchmark. So first is reproducibility. So I feel like since a majority of IR researchers like, in general, to reproduce things, and historically Trek has promoted a lot of collections which can be used for reproducible results. So we also wanted to come up with reproducible results in BEIR so that it creates, because if you have some complexity in the neural models, it creates some entry barriers, and reproducible results encourages other people to actually take their model or use those models to reproduce the numbers on their particular task. We also wanted to do some sort of standard comparative analysis. So the original BEIR paper, we would just have a lot of numbers in a table, and actually it's a bit difficult to understand or really say which model is better than the other one. So here we extended the work with some more comparative analysis, and also hopefully have some more easier visualization techniques which can give us more or help us identify more trends across different models. So we looked into some prominent and diverse set of models. So we looked at a lexical model, which is BM25. We also looked into the TASP and the Contriva model, which are both learned dense models, and also the learned sparse models, unicoil and splayed. And another thing which we wanted to look into in this whole paper is what sort of should be your best practices. Let's say if you're a newcomer and you want to see which model does well on your own task. So we wanted to identify these practices so that we can give those out as for you to reference so that you can use those for your own task. So the first thing is something which we actively promote in our lab back in Waterloo is something known as 2CR, two-click reproducibility in PySerini. And the good thing about this is we help you reproduce each and every model and on each and every BEIR data set using just 2 clicks. So if you actually just run the code, or this segment of code, and as well as another segment of code, you should be able to get the exact NDCG at 10 score for the corresponding model. And this is something which we added for the BEIR benchmark in this paper. So in order to illustrate the 2CR results, so as you can see, originally the BEIR dataset, and as well as you'll have a table with 18 datasets on the left-hand side, and you have 5 models, and you need to really look through all the numbers. So I feel like this can be really time-consuming at times. So in the paper, instead of more focusing on numbers and giving out them in a table, what we really liked is these concepts of sort of spider plots or radial plots. So here, what we plot is that BM25 is a circle, which is highlighted as the dot. And intuitively, you can imagine if the line is bigger than the circle, so the model is doing better on that particular data set. Whereas if the lines is kind of within the circle, so on that particular data set, the model underperforms BM25. So this is much more easy to visualize and help us easily understand on what data sets do actually different neural models outperform BM25 or not. So moving on to some best practices. So the first thing which we tried out was a flat versus a multi-field BM25. So the flat BM25, actually what it does is it concatenates both the title and the body together to index it in a single field. Whereas in the multi-field, you actually index your title and your body separately. So there were 2-3 decision choices you can make whenever you're doing a BM25 baseline, and we wanted to try out both and see what sort of results do we get. I have the radial plot on the right-hand side and also the average scores, which are mentioned in the bottom. But just a key takeaway would be that we didn't find any sort of clear winner between the flat and the multi-field technique. Often we also found that if you're doing a word piece tokenization in BM25, so that seems to degrade the effectiveness. Moving on to some best practices for longer documents. I think so this was one of the questions which was being asked. So we also tried some experiments where should we truncate the document to the first fixed 500 words or 512 tokens, and we also tried an experiment where we're doing a sliding window. So we're going from top to bottom of the sort of a Wikipedia document and taking sliding windows with a certain stride or a certain X amount of tokens. So what we found, again, with sliding window versus truncation is that with sliding window, the performance didn't improve significantly as comparison to the first P. A reason could be that many of the BEIR datasets are often short, so you don't really need to do sliding window, at least for domains such as like Wikipedia, so the documents are in general pretty short. So what we find is that first P is a good enough baseline to get a reasonable performance on BEIR. The last part is something which we were missing from the original benchmark, is sort of evaluating and benchmarking hybrid sort of retrieval approaches. So these days it's very common to actually sort of combine BM25 and let's say Colbert or let's say a dense retrieval model like TASP and finally give out the hybrid scores, which are ideally supposed to be the best of both worlds. So in this case, we also compare the hybrid sort of retrieval models against the individual models on the BEIR benchmark. So here what we found is that the hybrid models, so we combine the zero-shot splayed and the contriever models, and we would basically interpolate the normalized relevance score. So we would normalize each of their scores to 0, 1, and then combine them as a combination of score. And what we found was like the hybrid models would in general be better than the individual models, and it consistently outperforms BM25, but we found in 4 exceptions, BioAsk, Touche, Arguan, and Cora, where it will underperform. So talked about Touche, but it's like future work why it happens, sort of in other data sets as well. Another thing, so we've also do a meta-analysis saying that can we really say whether my model is better than a certain baseline? And in order to do that, we, like earlier in BEIR, we would actually report the average numbers, but sometimes the average numbers often is not meaningful because you have 18 different data sets which are talking about different things. So reporting averages sometimes are not really intuitive because you consider each data set to be an equal weightage there. So in this case, what we do is we take existing work from Xueguang, which has been presented at CIKM 18, and also the Ranger plots, which was introduced in certain et al. In ACL 2023, to actually understand whether on which data sets does your model really outperform and statistically sort of outperform the baseline. So if you see these 2 Ranger plots, the way to visualize it is, let's say you have a line on the middle, and if your mean and the range bars, if it's away from the line, then it shows that the model statistically outperforms the baseline on that certain data set. So you can look at the detailed Ranger plots in the paper if you're more interested. but what we found was that overall hybrid was found to be significantly better than both the models. So we evaluated hybrid versus Splade and hybrid versus Contriver. And yeah, so on Splade, we found that it is better on 14 out of the 29 different tasks, and on Contriver, 16 out of the 29. The reason it is 29 because CQA Dubstack is one of the data sets, and it has, I think, so 11 domains. Or maybe 12, but yeah, the sum adds up to sort of 29. So the key takeaways from the paper is that reproducible baselines in BEIR, so they often enable sort of a fair and trustworthy evaluation. That's why we wanted to more focus on reproducibility. We had some missing analysis of what should be the best practices of BM25, and we didn't initially benchmark some hybrid models, which we added now into the paper. And we also included some meta-analysis to determine, significance in BEIR, whether you can say a model is better than the other. Future work should be, what should be the next thing now? So we're done with V1, so how should you do V2? So these are like some of the more interesting questions which I think so we will try to tackle in the upcoming year. So yeah, that's it from my side. Thank you.